Hello everybody and welcome back to Learn with Levion. So I hope you guys had a wonderful time with me talking about Pluto last time. But this time we'll be going on to Earth's moon. So we finally made it to the moon's part. So you guys, if you haven't checked out our previous videos of the planet, you go to the top left or top right corner to see our previous videos. But without further ado, let's get started. So guys, remember when I talked to you about the planets where it influences its moon's rotation, orbit, and all that? Well, we finally made it to that part. So we're going to be talking about Earth's moon. We're going to be talking about what the moon is, how it formed, and what influences Earth has on the moon and other stuff. So, let's talk about when the moon formed. The moon formed around the time when the planets formed, though much later. It formed 4.5 to 4.6 billion years ago. So, basically, the moon is a rock. The moon orbits the planet and the sun. So basically, the moon goes apart an Earth-Moon system where it orbits the Earth and it also orbits the sun. So let's talk about how it formed. The moon formed when a Mars-sized object named Theia collided with the Earth, and some of that material turned into the moon, and it collided with proto-Earth since Earth was still pretty young at the time, and that's how the moon was created. So it was formed differently than So it was basically formed differently than the planets, but you'll get the concept of it. Now let's talk about what influences it has on the Earth. The moon helps control the Earth's rotation, because without the moon, the Earth's rotation will go extremely fast, with days lasting for 6 to 8 hours and longer nights. And the moon also influences why the Earth has tides at night. Without the moon, our tides would be created by the sun, but since the sun is very far away, the tides are significantly weaker when the sun causes them. So basically, the moon is basically our guardian protector of the tides. And also, without the moon, Earth wouldn't have been able to sustain its rotation with things going so fast. I mean, this would disrupt some things, and it would cause some pretty major things happening. And it also influences our technology, so if the moon disappears, it's going to be a disastrous effect on the Earth. Let's talk about what the moon has. The moon has many different things, and the moon is similar to the planet Mercury. The moon has a significant amount of craters. It has been inactive for most of its history. The last time it has been active was like 3 billion years ago, but then all of a sudden the moon became inactive, and which is why it's called a dead world today, because the moon is actually very similar to Mercury. The moon has many different features like past inactive volcanoes, terrain, massive craters, and the moon even has rovers, so we don't know how the moon became that inactive. because it's not like planets like Venus or Mars, which has a very interesting history, but the moon is different, so we do not know what happened during all the things that has happened during its history, so we don't know what it is. Now, let's talk about why it has been inactive. The reason why it might have been inactive is because the moon could have potentially dried out without any signs of volcanic activity, or the volcanoes were so powerful that the volcanoes became extinct, which is similar to what Mercury was in its early history, which is why the moon is extinct, has no geographic evidence for it having active volcanoes today. And since the moon is similar to Mercury, Mercury and the moon are considered both planet and moon similarities. But since it has some differences, it has a smaller core, and it has a bunch of other stuff that is different from Mercury. So, what happened during the moon's history could have been something major. Let's talk about the influences it has on the Earth and the moon, and the Earth's influences on the moon. So, the main reason why the moon is here is because it has an impact on our solar and lunar eclipses. So, the solar eclipse is when the moon passes in front of the sun, blocking the sun's light from reaching the Earth. But the moon misses most of the time. And most of the solar eclipses that happen are just partial eclipses, meaning that some parts of the sun is covered. That's because the moon is not perfectly aligned with the Earth, so many of the times it mists, which is why we don't see solar eclipses all the time. A partial eclipse is basically just the moon covering some parts of the sun, but still some of the sun's light reaches the Earth. But a total solar eclipse happens when the moon passes entirely in front of the sun, which is why it covers the sun. Now, in order for a total solar eclipse to happen, is that an object in the sky needs to be as large as or larger than the object that is covering. Since the moon in the sky seems larger than the sun, the moon can pass in front of the sun but sometimes it misses, which is why we don't see a solar eclipse all the time. Now, let's talk about a lunar eclipse. A lunar eclipse happens when the moon turns bright red. The moon turns bright red because instead of just maintaining its gray color all year round, it sometimes can become red, which is called a lunar eclipse, or a total lunar eclipse. A partial lunar eclipse is basically just some parts of the moon covered with red, and the other part not completely covered with red. And also, the moon also follows a cycle called the tidal, aka tidal locked synchronous rotation. But it doesn't always follow that method, so don't realize that the moon can be seen everywhere. It's at some parts of the Earth the moon cannot be seen, which is why you don't see the moon every single time. So the moon is not always visible. Now, let's talk about the moon phases. The moon passes through a bunch of different phases, from going from a new moon to a full moon. A new moon is basically the moon being 0% lit, meaning that we can't see the moon. A crescent moon is when a little bit of the moon is illuminated by the sun. A first quarter moon is basically the part of the moon is basically half of the moon is illuminated and of the other half is completely dark. Waxing gibbous is when most of the moon is illuminated. Then a full moon is when 99 to 100% of the moon is illuminated. And then it goes through these cycles from waxing to waning. A waning gibbous is when the moon loses some of its illumination. A third quarter moon or a last quarter moon basically means that it has the other half is not illuminated, the other half is illuminated. A waning crescent is when some of the moon is illuminated but the other parts are not illuminated. And it goes back into a new moon and it keeps following these cycles every single year. Now, let's talk about what are some of these craters' names on the moon. Now, some of these craters' names are known as the South Pole Aitken Basin. The South Pole Aitken Basin is basically a massive crater it covers much of the moon. So basically, this crater is over 8.1 miles deep and 1,600 miles in diameter. This crater is one of the largest craters in the solar system, larger than any other crater on the Earth. So guys, this is the Earth's moon. Now, so the Earth's moon is pretty much different from other moons because it's been inactive, but there's been some evidence that it has ancient lava plains and ancient stuff. So guys, we have covered what we need to cover for the Earth's moon today. In the next episode, we'll be talking about Jupiter's moon, Ganymede. So stay tuned for that video. And also, after we cover all the moons, we're going to go back and cover some facts we didn't really cover about in the planets and the moons. So that way we have all the facts covered on the planets and moons. So guys, I hope you enjoyed this video, and y'all can subscribe and like and come back for more. And also, quick question, I'm going to be quizzing y'all on what we learned today. How large is the South Pole Aitken Basin? So guys, if you know this answer, is either answer A, 7.1 miles deep, B, 5 miles deep, C, 8.1 miles deep, or D, 1 mile deep. So if you know this question, you can answer it. If you don't know, you may need some time and pause the video and think through it. So guys, I hope you enjoyed this video, and we'll see you guys in the next episode. Bye!